So I just stumbled upon these lockless channels in Crossfire that can handle async and blocking contexts. That's wild, right?
Wait, lockless. How does that even work? I always thought locks were necessary for safe concurrent programming.
Exactly, but Crossfire uses a spinning and yielding mechanism instead. It's designed to perform better by avoiding locks.
That's intriguing, but doesn't spinning waste CPU cycles? I mean, it sounds great on multi-core systems, but what about single core?
Good point, it actually can be a bit problematic on single-core systems. They provide a function to detect the platform for optimizing performance.
So kind of like an automatic adjustment. That's a clever design. But is there any downside to this approach?
Yeah, the algorithm relies on spinning, which can lead to inefficiencies in certain scenarios. But for most async situations, it shines.
I get that, but I'm curious about the performance claims. They say it outperforms other async-capable channels. How do they measure that?
They use benchmarking data. It compares Crossfire against other channels, and it shows significant gains in both async and blocking contexts.
Impressive, but benchmarks can be misleading. Are there scenarios where it doesn't perform as expected?
Definitely, they note potential hidden bugs, especially with atomic operations on weaker platforms, so it's not all smooth sailing.
That's an important caution. And what about the different types of channels? They have SBSC, mpsc, and mpmc, right?
Exactly, they serve different needs. SBSC is single producer, single consumer, which is memory efficient, while mpmc is more flexible.
So it's about choosing the right tool for the job. But is there a performance trade-off between them?
Yes, SBSC can be slightly faster due to its simplicity, but mpmc is necessary for more complex scenarios.
That makes sense. I wonder how the error handling works with these channels, especially when switching contexts.
Good question. They mimic the error types from Crossbeam channel, which includes errors for sending and receiving.
Interesting. So they've borrowed from an established framework. But are there any new error types introduced?
Not really, but they do add async-specific errors like send timeout error. It's like they're building on a solid foundation.
So what about the feature flags? I saw they support both Tokyo and async STD. Does that impact usability?
Definitely, enabling those flags allows for timeout capabilities in async contexts, which is super handy.
Right, but then you have to ensure your runtime is compatible. I can see potential pitfalls there.
Exactly. If you're not careful with your runtime version, you might run into unexpected behavior.
So overall, Crossfire seems powerful, but it comes with its own set of challenges. Is it worth the trade-offs?
I think it depends on the application. For high-performance needs, it might be a game changer.
True, but it could also complicate things if you're not deeply familiar with async programming.
Yeah, it's a double-edged sword. You really need to weigh the pros and cons based on your specific use case.
Absolutely. And those benchmarks, while impressive, should definitely be taken with a grain of salt.
For sure, it's fascinating to see how a tool like Crossfire pushes the boundaries of performance.
I agree. The evolving landscape of programming tools is always exciting. What do you think will come next?
Maybe even more innovations in concurrent programming. It feels like we're just scratching the surface.
Yeah, and with tech moving so fast, who knows what will be standard in another few years?
Exactly, but it's clear that understanding the underlying mechanics is crucial for any developer.
Totally. The more we delve into these topics, the more we see how interconnected everything is.
Right from performance to usage, every decision impacts the bigger picture in programming.
That's a good point. And this discussion about Crossfire really brings that into focus.
I feel like we've uncovered a lot here. It's exciting to think about the future of concurrency.
It really is. Let's keep our eyes peeled for further developments. There's so much more to explore.
Absolutely, and who knows, maybe next time we'll dive into another exciting tool or concept.
Sounds like a plan. I can't wait to see what's next on the horizon.